In this unit where we're working with polynomials, we've defined them, we've done addition and subtraction, and now we're going to begin multiplication. And one form of multiplication we're going to look at is to review the distributive property. And the distributive property is used when you multiply a monomial, a single term, times any polynomial. All right, so monomial on the outside, and we'll distribute it to however many terms are on the inside. When we do this, because we're multiplying, we're going to use the product rule with exponents. And remember that the product rule says that if you have x to the a times x to the b, that you get x to the a plus b. All right, so let's look at some problems. The first one, 2x times 5x plus 7. We're going to distribute. 5x times 2x gives us 10. We're going to add those exponents to get x to the second. Plus 2x times 7 is 14x. Those are not like terms, so we're done. Next one, negative 3a times a plus 4. Distribute. Negative 3a times a, both the exponents are 1s, that's negative 3a squared. Negative 3a times 4 is negative 12a. Once again, not like terms, so we can't combine them. Next, negative 5a squared times 3a squared minus 5a plus 3. We're going to use the distributive property. Negative 5a squared times 3a squared gives us negative 15. Add the exponents, a to the 4th. Negative 5a squared times negative 5a gives us plus 25. Add the exponents, a to the 3rd. Negative 5a squared times 3 is negative 15a squared. In the next few problems, we're going to extend past the monomial, which is what I mentioned in the beginning, and we're going to be multiplying a binomial times this trinomial, but we're still going to do it one term at a time. So I have x minus 3 times x squared minus 7x plus 6. All right, first I'm going to distribute the x. That gives me x times x squared gives me x to the 3rd. X times negative 7x is negative 7x squared. X times 6 is plus 6x. I'm going to switch colors so you can see. Now I'm going to distribute negative 3 times each of the terms. And I don't really have more room this way, so I'm going to go ahead and write underneath negative 3 times x squared is negative 3x squared. I've gone ahead and lined it up under a like term. Negative 3 times negative 7x is plus 21x. And negative 3 times positive 6 is negative 18. All right, like I said, I lined up like terms. Bring down the x to the 3rd. Negative 7 and negative 3 is negative 10, x to the 2nd. 6 and 21 is 27x minus 18. So I did combine like terms as I could. All right, let's do that one more time. I have x plus 4 times x to the 3rd minus 2x plus 3. First, I'm going to distribute the x. X times x to the 3rd is x to the 4th. X times negative 2x is negative 2x squared. X times 3 is plus 3x. Now, I'll distribute the 4. If I don't have a like term, then I'm just going to push it off to the side to write it down. 4 times x to the 3rd is plus 4x to the third. There was not one for it to line up under. 4 times negative 2x is negative 8x. There was one for it to line up under. 4 times 3 is plus 12. You don't have to line them up like that, but sometimes it makes it easier when you're combining like terms. I have x to the fourth minus 2x squared minus 5x plus 4x to the third plus 12. Now that is not the best way to write that answer. I usually want my polynomials in descending powers. So the best way to write that answer is x to the fourth plus 4x to the third minus 2x squared minus 5x plus 12. So I've multiplied, combined any like terms, and all I had that were alike were the x's, and then I reorganized using the commutative property. So that's multiplication using the distributive property.